Welcome to our video on standby generators for commercial environments. I'm Gary, your facility manager, and today we're going to explore how to size generators correctly, the potential issues with incorrect sizing, and how to optimize your facility's energy management. In areas like South Africa, where power outages are a daily occurrence, standby generators are in high demand. Many suppliers are eager to cash in, but not all of them know how to properly size a generator for your facility. Today, we'll learn how to avoid common pitfalls and ensure your generator is the right fit. Many suppliers base their calculations on the incoming circuit breaker's rating or your utility account. However, they often overlook factors like energy efficiency, peak demand times, emergency systems, equipment specifically excluded during outages, after-hour peak demand, and tenant participation. Now let's look at understanding manufacturers' recommendations. Manufacturers generally recommend that a generator should operate between 70 and 80% most of the time. Running within this range ensures optimal efficiency and reduces wear and tear on the generator. It also allows for some flexibility in case of increased demand or additional equipment in the future. So what are the consequences of incorrect sizing? Undersizing, oversizing a generator can lead to various issues. If your generator is undersized, it can then firstly trip out. The generator may trip out when the demand is higher than it can produce, leaving your facility without power during an outage. It can also overheat. Undersized generators can overheat due to the continuous high load, causing damage to the engine and reducing its lifespan. And then lastly, increase of wear and tear. Running at maximum capacity for extended periods can lead to increased wear and tear, resulting in more frequent maintenance and potential breakdowns. But then on the other hand, oversizing a generator can lead to 1. Excessive fuel consumption. Number 2, a shortened lifespan. 3, wet stacking. So wet stacking occurs when unburnt fuel accumulates in the exhaust system, reducing the generator's efficiency and potentially causing damage. And then lastly, number 4, glazing. Insufficient load can lead to glazing in diesel engines, causing a buildup of carbon deposits and reduced engine efficiency. Let's look at the right approach to sizing your generator. So proper sizing involves firstly analyzing your building's energy consumption patterns, then also establishing your tenant's needs, and lastly, establishing equipment requirements. By following these steps, you'll be able to size your generator correctly and avoid the issues associated with incorrect sizing. Thank you for watching our video on standby generators. We hope this information helps you to make informed decisions about generator sizing for your facility.